Well, welcome to our next lesson in Chapter 8 on special right triangles. This is a very important section, and I will expect you to be memorizing the relationships between the side lengths and the hypotenuse of these special right triangles. And so go ahead and make sure that you spend some time focusing on that. So to start out with, we're going to have two special right triangles that we will be talking about. And the first one is called a 45-45-90 special right triangle. And this is actually just an isosceles right triangle where the lengths of the two legs are the same. And in this picture, y is the hypotenuse and x is the length of the leg. And the relationship between those legs and the hypotenuse can be found just using algebra. If we use the Pythagorean theorem, we have x squared plus x squared equals y squared. And combining our like terms, we get 2x squared equals y squared. And then taking the square root of each side, we get y equals x times the square root of 2. So that tells us right there the relationship between the hypotenuse and the length of the sides. So the hypotenuse is the square root of 2 times the length of the leg. And that's what's in the formula right here for your 45-45-90 triangle theorem. Okay? So the hypotenuse is the square root of 2 times the length of the leg. So here's our first problem. Let's find the length of the hypotenuse. And in the problem on the left-hand side, we're going to start off. Hypotenuse is the square root of 2 times the leg, but we know the leg is 9. So the square root of 2 times 9 gives us 9 square roots of 2. We always put the whole number in front of the radical, and we're going to leave these in simplest radical form. On the right-hand side, we get square root of 2 times the leg, but the leg this time is 2 square roots of 2. So now we can combine these 2 square roots of 2, which is really the square root of 4, and the square root of 4 comes out as a 2, so it's 2 times 2, which is 4. So here's one for you to try. What is the length of the hypotenuse of a 45-45-90 triangle with the leg length 5 square roots of 3? Well, here we go. The hypotenuse is the square root of 2 times the leg, but the leg is 5 square roots of 3. So now we need to get these two numbers that are in the square roots or in the radical together, and the whole number stays outside of that. So the hypotenuse is 5 square roots of 6. Problem number 2, finding the length of a leg. What's the value of x? Same formula, square root of 2 times the leg. Now just substitute in what you know. This time we know the hypotenuse, which is 6. We're looking for x, which is the leg. So we're going to divide both sides by the square root of 2. And we get x equals 6 over the square root of 2. But this is a problem right here. This is called, we have an irrational number in the denominator, and in mathematics that's never allowed. So we need to do what's called rationalizing the denominator. We need to get rid of that square root of 2, and we do that by multiplying both the top and bottom by the square root of 2. Okay? So on the top we're going to get 6 square roots of 2, and in the bottom we're just going to get 2. Okay, the square root of 2 times square root of 2 is the square root of 4, and square root of 4 is 2. So now we can divide, 6 divided by 2 is 3, so we get 3 square roots of 2. If you have any trouble rationalizing the denominator, please let me know in class, and I can explain that a little more clearly if you didn't understand that. Here's one for you to try. We have the length of the hypotenuse is 10. Find the length of the leg. Go ahead and pause the video and try this one and see how you do. Alrighty, hope you had some success with that. Plug in the length of the hypotenuse is 10. And so we need to divide both sides by the square root of 2. But remember, we can't have any square roots in the denominator. We have to rationalize that denominator. So when we do that, we multiply top and bottom by the square root of 2. That gives us 10 square roots of 2 over 2. But now 2 goes into 10 5 times, and x is equal to 5 square roots of 2. All right, finding distance. We have a softball example. And this is our softball diamond. It's a square, and the distance from base to base is 60 feet from any two bases. We want to know how far does the catcher have to throw the ball from home plate to second base, so that's finding the length of that diagonal. Well, we do have an isosceles triangle, an isosceles right triangle here. D is the distance or the length of the hypotenuse. So we're going to say that that's equal to the square root of 2 times the leg, which is 60 square roots of 2. Now this time we can go ahead and plug that in and get to the nearest tenth, and we get 84.85 with a bunch of decimals, and we would call that about 84.9, I suppose, would be the best estimation. 84.9 feet. Here's an example for you to try. Pause the video again and see if you can figure this one out. Alrighty, this one says we're going to plan to build a path along a diagonal of a 100-foot by 100-foot square garden. So draw yourself a picture. We're looking for the diagonal. We have 100-foot by 100-foot. We want to the nearest foot. How long will the path be? Well, it's the square root of 2 times the leg is equal to the hypotenuse. So multiplying that out, we get x is equal to about 141 feet to the nearest foot. Alrighty, so the second special right triangle that we're going to be working with is a 30, 60, 90 right triangle. And all of the sides are referenced to the shortest side. Okay, so if we call the shortest one S, the longer one is the square root of 3 times S, and the hypotenuse is double the shorter one, 2S. Okay, so that's the relationship you need to remember. So let's go ahead and solve a problem. It says, what is the value of D, looking for the shorter leg, in simplest radical form? Well, we know the longest leg is 5, okay, and the longer leg is the square root of 3 times the shorter leg. Well, if the longer leg is 5, we can plug that in, and we can solve for D, divide both sides by the square root of 3, and then rationalize our denominator. Gives us 5 square roots of 3 over 3, so that is what D is equal to. Here's another application of the 30, 60, 90 right triangle. In jewelry making, we have a pendant here where the length of the hypotenuse is S and the height is 18 millimeters. They want to know what is the length of that hypotenuse S in each side of the pendant to the nearest tenth of a millimeter. Well, we know the hypotenuse is S, and the shorter leg then is half of that, or 1/2 S. So we can substitute in the longer leg is equal to the square root of 3 times the shorter leg. And so the longer leg is 18, and that's equal to the square root of 3 times the shorter leg. The shorter leg is 1/2 S now. Okay, instead of being S, it's half of S because this hypotenuse is twice as long as the shorter leg. So if they called this hypotenuse S, this has to be 1/2 S. Alright, so let's go ahead and simplify that. We get the square root of 3 over 2 times S. But in order to simplify this, to get rid of this square root of 3 over 2, we got to multiply both sides by the reciprocal, which is 2 over the square root of 3. So we're going to multiply by that. And then 18 times 2 is 36, and 36 divided by the square root of 3 on a calculator gives us that decimal number. I would call that about 20.8. Here is your lesson check. Please be sure to do all 4 of these problems and have those ready to turn into class tomorrow. See you next time.